In the next exam question, a ball is thrown vertically downwards from the top of a building and bounces a few times as it hits the ground. The velocity time graph below describes the motion of the ball from the time it is thrown up to a certain time t. Take downwards as the positive direction and the ground as your zero reference. The graph is not drawn to scale and the effects of air friction can be ignored. Now, before we have a look at the questions, we will first have to interpret this graph. From the graph, I can see that my ball starts with an initial velocity of 10 meters per second, and then the velocity is increased to a velocity of 29.6. Now, for the first projectile path, I have an initial velocity of 10 and a final velocity of 29.6. Now, seeing that my velocity increased, it means that this motion is in the downward direction. It was also said that we have to take downwards as positive. This means that everything on the positive part of my y-axis is in the positive direction, which is downwards. And therefore, everything on the negative part of my y-axis will indicate my upward direction. When my ball is thrown with the initial velocity of 10 meters per second and it reaches the 29.6 meters per second just before it hits the ground, it suddenly changes from a downward to a upward direction. So the dotted lines in the graph indicate a bounce. After the bounce, my ball has an initial velocity of x, it moves upwards, and it reaches its highest point when the velocity is equal to 0. At the highest point, due to acceleration, the ball then moves further downwards and reaches a final velocity of 27 meters per second. It then bounces again and moves upwards with an initial velocity of 25 meters per second, until it reaches its highest point again at time t. In many cases, it makes more sense to take the velocity time graph and plot the position time graph to understand better what happens to the motion of the ball. Now, my ball starts with an initial velocity of 10 meters per second, and it was said that it was thrown from a certain height of a building. We can call this height x. Due to acceleration, my ball then accelerates downwards until it reaches time 2. The ball is then in contact with the floor from 2 to 2.2 seconds. Thereafter, my ball moves upwards until it reaches its highest position again. It then moves back downwards until it reaches 7.7 seconds. It is in contact with the floor from 7.71 to 8 seconds and then moves back upwards to its highest position. Now, for the velocity time graph, downwards was taken as positive. The position time graph we drew using downwards as negative. When taking downwards as negative, we get a projectile path in the position time graph of a ball bouncing. Question 3.1 says, write down the speed with which the ball is thrown downwards for 1 mark. Now, the initial speed with which the ball is thrown downwards is 10 meters per second, which we can take from the graph. Question 3.2 says, all parts of the graph have the same gradient. Give a reason for this for a total of 2 marks. Now, the gradient that they are referring to is this gradient. Now, in order to understand what the gradient is, we can have a look at what the gradient in this graph would give us. To calculate gradient, it is the change in position of your y over the change in position of your x-axis. Now, on our y-axis, we have the change in velocity, and on the x-axis, we have the change in time. And the change of velocity over change of time is the same as the rates of change of velocity, which is equal to acceleration. And the acceleration that a body in free fall will experience is equal to our gravitational constant, which is equal to 9.8 meters per second minus 2. Now, seeing that the gradient is equal to a constant, it'll give me parallel straight lines in my velocity time graph. In 3.3.1, we are asked to calculate the height from which the ball is thrown for a total of 3 marks. In order to solve this problem, I need only to make use of this initial projectile path, where I have an initial velocity of 10, a final velocity of 29.6 just before it hits the ground, and it takes a total of 2 seconds for this motion to happen. From the information that we have, we can make use of equation 2 to 4 in order to solve the change in position. For vertical projectile motion problems, there's always more than one way in order to solve the problem. In these video explanations, I will only have a look at one of them. Now remember, for this problem, down is positive, and seeing that everything is in my downward direction, all the values that I substitute into my equation should be positive. The ball was therefore thrown from a height of 39.6 meters from the ground. In 3.3.2, we are asked to calculate the time t as shown on the graph. So we are looking for this time t. Now, seeing that this projectile path starts at 8 seconds, we can use this projectile path in order to calculate the time it takes from its initial velocity to its final velocity, and then just add that to the 8. Now, the initial velocity we can see from the graph is given as 25 meters per second. The negative indicates that it is moving upwards. It moves upwards until it reaches its highest point, where the velocity is equal to 0. Seeing as we have both the final and initial velocity, as well as our constant acceleration, we can calculate delta t using the first equation of motion. Which gives us a time t of 10.55 seconds. In 3.4.1, we are asked to write down the time that the ball is in contact with the ground at the first bounce for a total of 1 mark. Now remember that the dotted lines indicate my first bounce. It hits the ground at 2 and it leaves the ground at 2.2. It is therefore in contact with the ground for 0.2 seconds. 3.4.2 says write down the time at which the ball reaches its maximum height after the first bounce for a total of 2 marks. Now remember, this is the first bounce, and after the first bounce it reaches its maximum height at 4.955 seconds. So remember that at the highest points the velocities are always equal to 0. In 3.4.3 we are asked to write down the value of x for a total of 1 mark. Now x is the initial velocity after the bounce that the ball will move upwards with. Now the ball moves up, reaches its maximum point, and moves back down. It hits the ground at a velocity of 27 meters per second. Now, seeing that the ball is in free fall, we only have gravity working in on this body. If the ball hits the ground at 27 meters per second, it should move away from the ground with the same velocity in the opposite direction. Now, seeing that they are asking for value x from the graph, we need to indicate the negative. In 3.5, they ask, is the collision of the ball with the ground elastic or inelastic? Give a reason for your answer using information in the graph for a total of 2 marks. Now remember, for a collision to be elastic, the kinetic energy of that collision needs to be conserved. And if kinetic energy is conserved, the velocity needs to be conserved. So this means that if the collision of the ball with the ground is elastic, if it hits the ground with a certain kinetic energy, it needs to leave the ground with the same kinetic energy. Therefore, it would reach the same height. And this would continue on, seeing as kinetic energy as well as velocity is conserved. From our graph, we can see that velocity is not conserved. The ball hits the ground with a velocity of 29.6 and leaves the ground with 27. Therefore, some energy was lost during the collision. Therefore, this collision is inelastic, seeing as some of the energy is lost during the collision.